we can just close down some of these tabs. I've got my cue cards in one of my pockets here. Open these up. Go full screen. Cool. So hopefully this is the talk that you guys are all interested in. My name is Chad Furman, and I will be talking about the top 10 web application security vulnerabilities and giving a demonstration on how to hack into websites that are vulnerable to them using Burp Suite. Other tools that I will cover include the Mutillidae web application, which is a vulnerable web application, SQL map, which is an extremely powerful command line tool that we'll touch on briefly, and the browser exploitation framework. That's not actually the food product. Beef is an XSS exploitation tool. I have a lot to get through, so I'm going to move kind of quickly. I don't really have too much time to dive into how SQL works, why SQL injections do what they do, that kind of stuff. But hopefully by the end, you'll have a general understanding of the subject. So the reason why we're talking about this kind of stuff is because it's really useful for people who want to become penetration testers. Penetration testers help out in bug bounty programs. You can make thousands of dollars if you find one of these vulnerabilities in a real website. You can help open source projects. If you're a web application developer like I am, you really want to know this stuff so that you can fix your websites and not run into trouble. It's also just a good skill to have. It's kind of fun to know. So like I said, I am a web developer. I've been doing full stack development for about 10 years. I work at this company called CleverTech, full-time, 100% remote web development. If you're interested and you know your JavaScript, let me know. So these are the top 10 vulnerabilities, and we'll cover them a little bit more in the next slide. But basically, injection allows you to inject code where it's not supposed to be. Weak authentication and session management allows you to get authorized where you're not supposed to. Cross-site scripting lets you execute JavaScript on somebody else's website, which can do a lot. Insecure direct object reference is like ID enumeration, direct access to system files, that kind of stuff. Security misconfiguration will let you fingerprint websites. Infrastructure, as well as show you like error messages on the site that can reveal a lot of data. Sensitive data exposure includes things like unencrypted credit card numbers, traveling in clear text, weak ciphers, old versions of SSL, that kind of thing. Missing function level access control is like an endpoint should require admin access, but it doesn't. Or again, you can access files on the system, like for example, Etsy password that you probably have no business accessing. Cross-site request forgery allows you to make a request from your website to another website, thus taking advantage of the fact that your session ID transmits in a cookie, and you can execute things like adding data to other people's blogs with them being logged in on that site, but on yours. Components of known vulnerabilities is kind of straightforward. Old versions of WordPress, WordPress plugins, vulnerable versions of PHP, unvalidated redirects and forwards might seem kind of innocent, but if you can control the page that a user ends up to, you can basically, they go to this website and then they get redirected to your website. It looks like the other one. You can ask for their username, their password, download files, that kind of stuff. So the things in bold are the things we're really going to try and focus on. I'm going to spend the most time on SQL injection because it's awesome, it's powerful, and it's everywhere. There's lots of different kinds of SQL injection. We're not going to talk about blind SQL injection here. Just know that if you can't see an error message, that doesn't mean that there is no SQL injection. You can inject things like sleep commands or ASCII arithmetic and just kind of see from the result if SQL injection is there. Select and insert injections differ in how you exploit them. MySQL doesn't have the ability to do string concatenation. You can't chain queries. You can't union in another select statement inside of an insert statement. So you have to kind of take advantage of what there is available. But basically, we'll go over this more in depth. Just know that for select, the main kinds of attacks are in-band attacks, where you're actually using the query as is. unions where you're bringing in a new query and pulling out data. And you're really going to take advantage of the group concat command to squish things into a string. Insert injection is very similar in the sense that you can do in-band injection. You can also do error injection, where you actually want it to error because you can see the error and you can reveal data that way, and we'll do that. Also, a neat little trick that I don't want to talk about right now is that strings are actually 0 in MySQL, and that results in some interesting behavior. An SQL map, of course, we'll talk more about that later. Weak authentication and session management, there's lots of ways that this can expose itself. We're going to focus primarily on authentication bypass, cookie manipulation, and session replay attacks. Cross-site scripting has 2 kinds primarily. First order and second order. First order attacks are called reflected attacks. That's when you have data in a request that gets reflected on the page. Stored attacks are second order attacks. They basically, you submit data in a form, it gets stored in a database, user goes to the page, XSS displays. You can use this stuff, and we will use this stuff to steal cookies, do session replay attacks. You can do lots of things. You can rewrite the page, trick users to downloading backdoors, root their PC, all a simple JavaScript injection on a web browser. Beef is amazing. I'm a vegan, again, I don't add, but the exploitation framework is super powerful, and we'll just touch on it briefly. Insecure direct object reference, and again, I'm going fast because we got a lot to get through. Insecure direct object reference allows you to, again, directory traversal, including files that you shouldn't include, ID enumeration, we'll do all that. Looking for things that should be encrypted but aren't. Unencrypted storage transport, that's sensitive data exposure. The strict transport security flag should always be there. Cross-site request forgery, cross-origin resource sharing flags should be restrictive, nonces should be present. If they're not, you can have a button on your page that when a user clicks it, triggers an action on, for example, Facebook, if there's a CSRF vulnerability in Facebook, or you know, whatever application you're testing. Components of known vulnerabilities, we've touched on this briefly, but old versions of PHP, PHP 4 is no longer supported. There's lots of security vulnerabilities for that. It's also a pain in the butt to migrate to PHP 5 if you don't have the resources. So some vulnerabilities exist for old websites. Frameworks themselves can be vulnerable. Old versions of Cake, WordPress, that kind of stuff, Drupal. There's always security updates. They always tell you to update. Sometimes it breaks your plugins and you don't. And again, client-side redirects are what we are going to focus on for the 10th item here, unvalidated redirects and forwards. So let's go ahead and try and dive right into this. Wish me luck. So let's see. The infinite tunnel. So I need that to get smaller. I actually just need that to stay open, but the application to get smaller. There we go. Okay, cool. Let's come back to that. So before I dive into Mutillidae, we are going to take a look at Burp Suite. So Burp Suite is the tool that we will really be taking advantage of here. In the top left corner, you can see it's got a target, and my sitemap, I did clean it out, but I'm going to just clean it out again really quick. Happened because I loaded the page. So in the top left corner, we've got the target tab, which allows us to specify our scope. So here I have the scope specified as my local Mutillidae application. That prevents me from bringing in resources from AWS or other external resources on accident, things that I don't really care about. The proxy is how things are getting in here. So under the options tab in the proxy section, I have it set to, let's go to the top here. I've already configured my browser. You have to make sure that little running checkbox there is checked for this to all work. In these two sections down here, intercept client requests and server responses, you want to make sure that the checkbox for the filters are enabled, as well as this little and field to only proxy things that are in scope. I also find it helpful sometimes to turn off the WebSocket messages as well, but to each their own, depending on the application. We're also going to start with proxy intercepts off. We'll turn that on at some point. That blocks all of our requests and allows us to manipulate data in transit. So tabs we won't talk about are spider and scanner. Basically, the spider will automatically crawl a website for you, following all of the links and populating your sitemap. Scanner is a feature of Burp Pro. I spent the $300. It's $300 a year. You get Burp Pro faster, more features. This is an automated scanner. Put it as a domain, and it will just dump out all the vulnerabilities across all of the pages. Excellent tool if you're actually doing this stuff professionally. But for our purposes, it's cheating. We will use the intruder a lot. The intruder allows you to take a request and specify which parts of the request you're interested in. Define different attacks. You can have different payloads for each attack, same payload for all the different fields. Specify different fields and data dump in them, and we'll go through all of this. The repeater, again, is another tool that I love. You take a request, put it in here, and it allows you to send the same request over and over and over again with different data. Sequencer is really good for decrypting tokens. So if you have like password reset tokens with pseudo random number generators behind them, and you want to predict what the next one might be so that you can reset somebody's password, or to see if that vulnerability exists. The sequencer is really good for that. We won't play with it too much here. It's a little too technical at the moment, and we've got lots of low-hanging fruit to just demo. The decoder allows us to switch between plain text, URL encoding, base64, lots of different stuff, and that can come in handy on occasion. So you have two chunks of text that you think are different, and you're not sure how. The comparer will help you figure that out. In case you're injecting something and you think something's changing, but you're not sure where, this will help you find it. Burp's extremely extensible. It comes with lots of different plugins. It also comes with API documentation, so you can write your own. You can write it in Java. I think you can write it in Ruby and Python. So a very powerful tool. So that's enough about Burp for now. Take a look at the target here. It's blank at the moment, so let's go to the page. Here is Mutillidae. Mutillidae is a tool built by a member of the InfoSec community known as Iron Geek. And I'm very grateful for his work in this. Basically, over in the menu here, you have a list of what were the top 10 vulnerabilities at the time. Just because these are the top 10 doesn't mean that's all there is. The top 10 changes every now and then. So we're going to start with, this menu is a little delicate here, user info extraction. This will allow us to dive into SQL injection. Now, SQL injection is basically the fact that you can enter a single quote or a double quote in a URL field, and it breaks stuff. So in this case, we enter a single quote, and we are literally altering the SQL query, and it thus becomes invalid. So this one also happens to be revealing sensitive data about the system. It also happens to be a security misconfiguration. So we've got 3 right off the bat with a single character entered into a form field. The security misconfiguration, of course, is that we see this error message that reveals not only the exact form of the query, but also the file path to the file being executed. So we know that this website exists in var www, Mutillidae, etc. So that's all fun, we built it, but what else can we do? The classic MySQL injection is that. And what that means, it's a single quote or 1 equals 1, and the 2 hyphens at the end are important. So this is a tautology. We're basically taking the query as it is, injecting an always true conditional, and then commenting out the rest of the line. Now, it's very important when you do this that you have the space here at the end and before the comment. Otherwise, it won't work. So when we do that, it actually evaluates to true for all of the users in the database and just dumps them to the screen. In this case, we can see that the passwords are stored unencrypted. That, again, is sensitive data exposure. So we should be aware of that. But this is cool, right? We can see all of the users in our database. So we have just successfully exploited our first vulnerability. Hooray! But we can do more with this. We can actually do a lot more. This is just all of the users in one table. Well, what other databases exist on the system? We can find this out by pulling from the information schema table. But before I do that, I want to talk about how that will actually work. Previously, we just joined in an extra conditional to make it always true and match all of the rows in the database. Here, we're going to pull in an additional query. Now, the interesting thing about the union statement is that the queries have to have the same number of rows. So when you do it the first time, you're going to see there's a different number of, of columns. I misspoke. Different number of columns. And what you do is you successively add nulls to the query until you match. So in this case, I know it's 5. I'm just going to save us some time and dump that in. See what that's like. And so here we get back our null result. So if we go and we modify those, and you would modify each one at a time with a single string of a character, and see if it appears on the page. And the goal here is to figure out which one of those fields maps to an item on the page that you can see. When we find one, that's really all we need. So now we found that the username is a string, and we can control it. So let's, for example, dump out the database that we are working with. Also dump out the version of the database platform, etc. So we can also pull from the information schema database in MySQL, and it has a table called tables. And in tables, there is a column called table schema. This represents all of the databases in the system. We will concatenate all of the database names with a comma. And it's very important when you do this that you order by a field so that the group concat statement will work. And we're going to dump all of that into the one field that we've recognized as a string. And I'm sure you can imagine what this will look like at this point, but here are all of our databases, including the one we are currently in. So what if we wanted to find out what tables are in our current database? Very similar, this time we're going to pull the table name where the database is the one we are in. And see if there's anything else interesting in here that we might want to explore. Something like, for example, credit cards. Well, there's a credit card table. Password is stored in clear text. Let's see about the credit cards. So this way, we're going to actually explore the credit card table. We are now pulling the names of the columns from the columns table where the database and table name match our interests. And so we can see these are the table name columns that we're working with. And so if we pull them out, we can basically select each one, separate them with the concat command, and get credit card information. Interesting fact, there's more null statements here. So we could pull them out one at a time, but I happen to know that the third and fourth null statement correspond to the other two fields on the page. So if we just repeat that among both of those, we can pull credit card numbers out at a time. So SQL injection allows you to pull data out of the database, but it also allows you to get a shell on the remote machine. And not many people know this, but you can actually use the fact that, actually I'm sure security professionals know this, but I thought it was interesting when I learned. You can use the fact that MySQL is a command called into_out_file, and you can select a raw string directly into a file on the machine. So my immediate thought is that, well, the server is serving websites from the Mutillidae folder. Let's try and create a file in the Mutillidae folder. This, if you don't know PHP, is just taking in a URL parameter, execing it, basically running it on the machine and spitting out the output. If we dump that in, we're going to get an error that says that it can't write to that file. Well, that's okay. You don't win them all. What you can do, however, is write to a very commonly writable file, /temp. Same query, just a different file. When we execute this, it succeeds. Now, how do we execute /temp? Well, in order to make that work, we have to take advantage of the fact that this website is vulnerable to something else. If you look in the URL up there, we've got a page parameter. That page parameter is including files directly. So let's see if we can include our new file. simply tell something. And we're also going to pass an additional parameter, the one that we're execing. See what happens. It lists out the files in that folder. Now from here, you can do, of course, echo, whatever, just to test it a little bit more. But you could do netcat commands, give a reverse shell, write system files, whatever you want. The machine is basically owned. You might need to do a little privilege escalation, but you have a shell through SQL injection. Pat yourself on the back. Moving forward, I also want to touch on the difference with insert injection. So the rest of the talk, we aren't going to spend as much time on any one item, but there's a lot here. So before we go on insert injection, let's note that we're not actually logged in. We did all of this without ever being authenticated to the website. But what if we wanted to log ourselves in? Could we log ourselves in with an SQL injection command? We are now the admin, if you look in the top right-hand corner. Why did that log us in as the admin? Well, it's going to match every user in the database. And the very typical pattern is that the first user in the database is the admin. So it's going to pull the first user that it matches and log us in as that person. So with a simple basic SQL injection, we are now the admin of this website. What if we wanted a real account? Okay, well, if we wanted a real account, let's go to the register page and make one. So just kind of, force of habit here. Let's dump in some JavaScript in this big, beautiful text box and see if it executes. So I'm just making an account, giving it a cool little signature, create my account. Looks like it creates fine. See what happens when I log in as that account. Oh, look at that, little JavaScript pop-up box. Now that's going to be annoying. It's going to come up quite a few times, but it's there. So that's kind of an intro to SQL cross-site scripting as well. But let's go back to that form for a moment. So select statements can be used to exfiltrate data, but insert statements can also be used to exfiltrate data as well. So the obvious use of an insert statement to pull out data is to make a user and just do an in-band attack. So here, what I'm going to do is insert down here at the bottom. I'm just going to insert the database version. So this command is going to end the field that's currently being inserted and then replace the next field with the data that I want to get out. In this case, it's, like I said, just the database version. We're overriding the signature field. So when we log in as this user with password ASDF, our signature up there is the database version. So you can pull out lots of data that way. But if you didn't know how many columns there were, or you weren't able to do that for one reason or another, another neat trick, of course, is error injection. So you can do, in this case, we're going to take advantage of the fact that the name const function in MySQL will actually evaluate before the error is returned. So I'll skip the first one for the sake of time, but what we are doing is adding a query into our insert statement that is pulling from a query with duplicate column names. And the duplicate column names are the value that we're trying to pull out of the database. So if we were to run this, by the way, my cheat sheet is online at my website, and I will show that to you guys. We can see that we have injected an error, and the error message that we can see, which is a key part of this, contains the data that we're interested in. But if we couldn't see the data, we would, so, these are just other examples of how you can use it. Before I move on, I just want to touch on the fact that name const in newer versions is limited to just the version of the database. So if you run this command here with select2 and you get back incorrect arguments, then you can't use it. But if you get back duplicate column name, which we would if we did it, you'd be good to go. You might be able to get away with XPath injection, invalid XPath injection, which will do the same thing. Some databases don't support it. This is a little tricky here, so I'm going to try my best. But basically, strings are 0. They're not just 0; they are a double, which means that they are 8 bytes. And because you can't do string concatenation, but you can do bitwise arithmetic, we can take advantage of the fact that the string is 0 to pull out data as a number in 8-byte chunks. And the way we would do that is like this. So we're going to break out of our query with a single quote, do an OR with a substring of the data that we're pulling out. In this case, it's the user of the database. We're pulling out the first 8 bytes, the first 8 characters of that data. We are converting it to hex from decimal. No, I'm sorry, we're converting it from hex, right? So we hexify it first, and then we convert it from hex to decimal. And that will give us a number. It's actually going to give us this number right here, but let me show you. And if we log in as dog, there is that number. Now, you can just open up a MySQL terminal and run the operation in reverse to pull out, oops. The 8 bytes that you extracted. So you can imagine this says root at localhost. So the database is running as the root user right now. And so that is, that's pretty much it for SQL injection. I did want to touch on SQL map really quick. This command right here with the -u flag says this is the URL we're interested in. The parameters are get parameters, so you don't have to specify any post data, but you can. So if we were to run this command in the command line, SQL map's going to hit the site. It's going to go a little bit, and it's going to say, okay, well, page might be vulnerable to a couple of different things, but and it's guessing at the database. Oh, look at that. Username might also be injectable as well. Yeah, I'm not interested in other database types. All tests. Yeah, include all tests, and it'll just run. And you can also specify a -a flag, which will literally dump out the entire database schema. You can specify the database server. If you know it happens to be MySQL, you can save yourself some time. But this will just run in the background. So SQL map will help you find SQL injection attacks if you don't find them manually yourself. So, moving on, we have covered SQL injection. We've also talked a little bit about weak authentication and session management, but let's touch on that a little bit more here. So we are currently logged in as user dog. What does our cookie look like? If we were to intercept with burp, intercept is on our request, and go to burp, we can take a look at our headers here. So we've got our cookie header, username is dog, user ID is 19, and it does look like I'm already hooked by the browser exploitation framework, but we'll just ignore that for now. And we've got a PHP session ID all the way in the end. So the interesting part here to me is the fact that it's got the username and the user ID. Well, we know that the first user in a database tends to be the root user, so the admin user. Let's try it. Let's change our UID to 1, allow that to execute forward, and now we're logged in as admin. So that is an example of cookie manipulation to get through privilege escalation in database. So moving forward, one of the other things that we already bypassed authentication with SQL injection I want to really get into cross-site scripting now. So we did basic cross-site scripting in the stored persistent example, where we created an account and it stored our XSS, and from there anybody who viewed our account details would be exploited. But if we wanted to do, for example, a first order attack, a reflective attack, let's see what that would look like. So for this, I'm going to use this pen test lookup page, which I happen to know is vulnerable. Let's get a request caught in our proxy here. And let's send this one to the intruder. So what I did is I right-clicked, I just clicked send to intruder, and that takes the entire request and drops it over here. So we can see these are all of the positions in our payload. I'm not interested in anything in the header right now, so we'll clear those out. Just focus on the tool ID in position 1 and this button text in position 2. See if any of those will reveal data on the page. So I'm going to choose the cluster bomb attack, which allows me to pick different payloads for each of those positions. And I'm going to put a unique string in each one of those. And then in the options tab, I'm going to make sure that I am checking for both of those strings in the result output. And that is really all that I need to do. So I'm going to start the attack. So this window is going to pop up. It's going to do all of my items on all of the different payloads. We're going to see all the way at the end that a string was found on this page. Let's go to the response tab and see where it is. It actually was echoed out into some JavaScript. So that's very common. Sometimes you'll see refers or browser versions in the JavaScript. Let's see how we could exploit that. What I have done is, at the bottom of this file, I have crafted a string that will break out of the JavaScript. It will insert a beef hook into the code, and then it will let the JavaScript continue executing without error. So if I were to paste that into our request, which I can also send to the repeater for easier access, and we know that it was the first parameter, which was tool ID. I'm going to paste it in there. Might be a good idea to URL encode it first, but I'm pretty sure we'll be fine. Now, interesting fact, of course, is that I just did this in the built-in Burp browser, which probably isn't going to execute our JavaScript the same way. So we can right-click and we can request this in the browser itself. So Burp gives us a URL that we can copy, drop in, and it will, my proxy is still blocking this here. It will continue, and the page will render with that code. So let's see if that code actually got injected. We search for hook.js. There it is. So our browser was hooked. So what does that mean? That means that in Beef, if we log into our admin console here, I think it's Beef, we've got our browser. And so again, there is a lot here. I'm not going to cover 98% of it. If you go to the browser and you go to commands, this top folder, browser, hooked domains, get cookie. So we are going to take the cookie from the client that we just got, and here it is. So they have their PHP session ID. Let's copy that. Go to a new private window here where we're not going to be logged in. Prove that. Excuse me. Here we are, not logged in. Intercept is on. Refresh the page. Come back to Beef or Burp. Beef, Burp, Burp. And change our PHP session ID in transit to their session ID. Allow it to continue. Page loads. And we are now logged in as that user. This is a session hijacking or session replay attack. And that is cross-site scripting. That's reflected cross-site scripting that we just did, but we had to do that manually. So what if we wanted to trick somebody else into doing it as a proof of concept? Well, we have our attack here. We can right-click, go to engagement tools, generate cross-site request forgery proof of concept. Copy that, this code that it generates, copy it, and paste it into an HTML file. SQL map is still doing its job. Don't care what it looks like. Open that file. So let's say that we put this button on our website, and for whatever reason, social engineered somebody to click on it. They click on the button, they come to the page, and again, we can see that hook.js is a feature of this page, not a bug. So cross-site request forgery is done. We also touched a little bit on missing function level access control because we were able to browse to some interesting pages. But let's see. We only browsed to our page. Can we browse to other pages that might be interesting? Oh, look at that. Let's see password. Okay. Well, what other pages are there? Let's go and find out. One of the interesting things about the intruder is that if we clear out all of these payload positions and make a new position that is actually the URL, add, like a sniper attack, payloads, clear out our list, and then pick a burp list that's already there for file names, a long list of file names. Let's just see what burp finds. So it's going to start this attack and it's going to enumerate through that list. If you don't have the paid version, this is going to take a long time. But the pro version goes a lot faster. And the interesting thing here is that you sort by length. And you'll find that some pages come back with a different length. That's a little bit different than page not found. For example, documentation includes credits. What is PHP info? Let's take a look. I think you do too. Oh, cool. Lots of information about the server, all of the different extensions they have enabled, everything is all right here. And I think I saw ImageMagick. I don't know if you guys know this, but ImageMagick had an interesting remote code execution vulnerability recently. Anyways, moving on. That's missing function level access control in a nutshell. Sensitive data exposure, we saw that. We saw the credit cards in plain text. We saw the passwords in plain text. You also want to check to see if strict transport security is enabled. I'm not really going to talk too much about that, but basically it's something in the headers. So, direct object reference, we did ID enumeration. We accessed files directly. Etsy password, for example, our PHP shell. Security misconfiguration, errors. We saw that. We saw a PHP info could basically be security misconfiguration. Oh, another thing to talk about really quick is on direct object reference, sometimes you'll find backup.zip, backup.tar.gz, the root of some of these web applications. You can download that. Swap files, if anybody uses Vim or Emacs, you can access swap files of some of these PHP code things and see their source. It makes it finding other vulnerabilities a lot easier. So in terms of security misconfiguration, if we look at this response, we can also see the Apache version, you can see Ubuntu, the operating system version, those are all vulnerabilities. But in terms of components with known vulnerabilities, do any of these have any? PHP 5.2.4, let's see. Yes, I picked that for a reason. How am I in time? Getting close. Google's our friend. CVE database details here. We've got some 10s. So in this case, it's only on Windows, but in this case, it's not. So there's remote code execution vulnerabilities in this version of PHP. So even if the web application itself was safe, the entire server is basically compromised. So that's known vulnerabilities as well. We found those via security misconfigurations that revealed the version of the software on the system. So the last thing that I really want to touch on is, and this one's quick. This is just unvalidated redirection forward. If you ever come to a website, you see, I'm going to copy this URL to make things a little bit clearer. In the URL, you see something like forward URL equals someplace. You can have a user, you can have that URL in a button somewhere or a URL shortener or something like that. And this will allow you to redirect them to any page you want. And if that page looks like the page that they thought that they were going to, and it prompts them to log in because their session expired, or download the newest version of Adobe Flash or something like that, then you get credentials or a backdoor on the computer. So at this point, I just want to say that you guys have been awesome. And my slides are here somewhere. Maybe I closed them. Give me a sec. Document here. Let's jump to the end quick. Done. So that's where we're at. This page here will also give you a link right at the top, https://chads.website. You can go there and get the slides. You can get the cheat sheet. And there's a lot of other stuff here. So this is where you can go to download Burp Suite. It's portslicker.net. If you're curious about other vulnerabilities and stuff, you can go to OWASP.org. If you want to be a full stack, work from anywhere, remote, full-time developer, go to hire.clevertech.biz, see if any of the openings match your skill set. And give a shout out to all of these awesome people on Twitter. And that is it. Questions? Yes.
I have a question. So mine is sitting, and how do I begin?
So the question, yes. So for anybody watching the stream, the question was, there's a lot of stuff here. How do we begin? I just want to say, like I said, I've been developing for years. I've been doing this a lot. Honestly, if you're curious, play with it. Learn Linux, learn the command line, set up a web server, learn some programming languages, figure out how things work, how they're supposed to work. And then as you know how things kind of are supposed to work, you'll start to learn, okay, that's what an SQL statement is. These are single quotes in an SQL statement. Here's where a new single quote can go, and this is why it breaks. So the more you know about the way things work, the more you can learn about how you can break them to make them work differently. So the biggest thing is learn. If you're curious about web application development and WebSec, then focus primarily on building web apps and learn JavaScript, learn PHP, learn SQL, learn any backend language that they could be using. The more frameworks you know, WordPress, Drupal, the more you'll know about where their files are, where vulnerabilities might exist in those files as well. If you want to know about buffer overflows and exploiting PHP or Apache, then learn about systems programming, C, memory management, all of that stuff. There's a lot to learn. But the cool thing is, you're not going to run out of stuff to play with. Next question.
What's your relation to CleverTech?
I am a full stack developer. I've worked at CleverTech for almost 2 years. I love my job, and if you work there, I hope you will too. Cool. Yes.
So if you happen to rent a box somewhere and, you know, it's a full-on distribution, should you shut down the things that you're not, you know, using? I mean, what's your recommendation?
So the question was, if you have a server that you're renting from some company and their service is running on it, how do you harden it, basically? And that's that could be a talk in and of itself. But yes, a good place to start is to shut down all of the services you're not using. Make sure all of the services you are using are up to date and configured according to best practices, which is kind of like a magic hand wavy, you know, best practices. You'll have to know what those are for each of the things that you're using. But it's a constant battle to really lock things down. And that's why these vulnerabilities exist. And you had a question.
Yeah, so we look at we Google for vulnerabilities in PHP 5.2.4. Is it automatic that if I have a Drupal site or a web or a WordPress site running on that version of PHP, is it automatic that those vulnerabilities are exploitable?
So we Googled for PHP 5.2.4 vulnerabilities because it was in the header information, and we wanted to see if there were any known vulnerabilities. Because PHP 5.2.4 had a remote code execution vulnerability in it, that allows an attacker to inject code and run commands on the server. The first command that an attacker would try and run is one that will establish a reverse backdoor to their computer. It's a reverse backdoor to bypass incoming proxy or firewall rules. And that reverse backdoor will allow the hacker to, for example, rewrite your index.php page in your application to do whatever they want it to do. So yes, if your infrastructure is vulnerable, no matter what application you're running on top of that infrastructure, you are owned. Yes?
Although only if somebody can contrive to get, if it is something that you can talk to via PHP directly, but a lot of applications don't necessarily exercise the particular vulnerabilities that are there. So you have to know that Drupal actually is going to use some vulnerable function and that you can contrive to get it to do something.
True in part. So the statement is that if the application is not necessarily using the vulnerable parts of the service, then your application isn't vulnerable. So I say it's true in part because if PHP is running as the www user and your application is not related to the www user, the intruder would have to escalate their privileges in order to gain access to your application and compromise it. In the case of Drupal and WordPress running on PHP, if somebody can cause PHP to execute code, they can then have the access of the PHP daemon and write to the files that the PHP daemon can access. Now, if your files aren't writable by PHP, then you could be safer, yes. But that's a matter of systems permission and goes back to the lady's question about hardening your server. Having the correct permissions on all of your files goes a long way. So yes, absolutely. But if it is writable by PHP and a vulnerability exists in, for example, ImageMagick, and the attacker can somehow access ImageMagick, even though it's not through your application, and exploit it, then they can get access to the server and go from there. So good, I like that. Anybody else? We still have a few minutes here. I did go really fast. Yes.
So, I mean, the title of the talk was with Burp Suite. Burp Suite is your go-to tool for this. Are there other tools that you use?
So the question is, outside of Burp Suite, what other tools are available to do this kind of stuff? So there's Nessus is a very common tool for scanning for infrastructure and infrastructure vulnerabilities and other low-hanging stuff like that. Metasploit is a pretty good tool, but it's not necessarily a scanner. You can hook Metasploit up with Armitage, which will help you detect vulnerabilities in services running on computers. There's other tools outside of Burp Suite, like the OWASP Z-Attack Proxy or OWASP ZAP, which is useful. There's also an OWASP XSS tool, which is useful as well. I use Burp because it's the first thing that I learned, and it's fairly widely known. Plus, I have a professional license for it. So.
How important is the professional license? How useful is it without that?
So without it, you have access to the intruder, the repeater, the extender. You have access to the proxy, the sitemap. You can put things in scope. So you can get a lot out of Burp with the free version. But for example, the intruder, where it was brute forcing the list of directories, and it was just going through like hundreds of them every second, you're throttled to 5 a second with the free version. There's also, I mean, if you're gonna build a web application, you wanna audit it, and you're gonna be doing that a lot, you just wanna point the scanner at it and push a button and see what the scanner can find. Because the scanner will find most, if not all, and then more of what we just covered. So it's I mean, I've been, and I don't necessarily recommend this, but I've been on a project where we were tasked to audit someone's web application. We literally just pointed the scanner at it, pushed the button, and then documented the results and the meaningful vulnerabilities and how they could be exploited with proof of concepts. Now, there is always, you know, that's like, this website was, it was like Swiss cheese. So that's a good way to just kind of say, hey, your current development team is missing the mark, hire us and we'll do it better. That's really the whole point of what that was all about. But if you're auditing a hardened website, just because the scanner doesn't find anything doesn't mean there's not something there. Cool.